Good morning, everyone, and welcome to the VWT Open Forum. My name is Michael Lind, and I come from the Research Institute of Sweden, and we are very happy to run this session today. We will make a recording of this session for those that cannot attend. So if you do not comply with the recording, we ask you not to speak during the meeting. We also ask everyone that is running the note takers or the automatic note takers to disable those. Please mute yourself while not speaking and only open up the mic when you are speaking. And if you have any questions, we ask you to put them in the chat together with your name and email address if it is the case that we don't have time to reply to your questions during the session. Myself and the team within RISE have spent almost 2 decades now in understanding how we can leverage data sharing for the better good for our industries and data sharing. And if we think about a passenger transport, as this initiative is very much about moving cargo all over the world, if a passenger transport was organized like cargo movements and we missed our connection at a transport node, we would be asked to sit down and wait for the plane or any other mode of transport to come back again. Then, when the vehicle is back, the carrier will see whether any seats are available to bring us to our destination. If we are lucky, we travel. Otherwise, we may sit there some weeks. This is not how passenger transport works. It is much more flexible, and carriers offer us options. So today we will talk about the Virtual Watchtower initiative as one initiative that is leveraging on data sharing. We will organize this open forum, which is strongly having participation from VWT community members in exploring the VWT concept, providing some insight in the technical setup. We will pursue a demonstration of something that is now being monitored by VWT. We will make some outlook, and we will also finalize this 90-minute session with a Q&A. So what we see here is that data is needed to align, coordinate, and understand options. Cargo has no legs, and therefore we need to align between each other. Data then becomes the link between the actors in the supply chain. However, we also need to stress the fact that there is no large-scale digitalization without any large-scale collaboration. And what we see when it comes to data sharing in the cargo industry is that there are at least 2 challenges that are causing the lack of transparency, misalignment, cost, and frustration. Data is not always shared, is one of the challenges, and data is often not reliable, is the other one. So what we wanted to pursue is the Virtual Watchtower VWT initiative that is shipper-driven, terminal-centric, distributed as a novel approach to primary data sharing, primary and private data sharing. So the VWT initiative was launched as a result of the collaborative agreement between Singapore Maritime Institute and Research Institute of Sweden, where we said that there is one component that we would like to push when it comes to the collaboration, and that was supply chain innovation and innovation. What we also wanted to say in that collaboration was that these initiatives that Singapore and Sweden take together would not be possible for the one party to realize by themselves. We also said that with this initiative on VWT is that we wanted to explore a collaborative ecosystem, which we coined as a VWT community. We are very proud of that during these 2 years, we have moved from 23 partners to 50 partners, at the same time as we also wanted to explore the technical component, which we call the VWTnet. So it's all about having a community of trust that is co-creating a digital architecture that we call or coin as VWTnet. And what you see here now is how the partner setup looks like, that we have managed to attract. When saying we, is the VWT community of joining forces in actually coming to a situation where we do have a lot of representatives from the global supply chain industry. We do have research institutes. I will come back to those. We do have shippers, in other words, BCOs or beneficial cargo owners and freight forwarders. We do have transport operators. We do have terminal operators, and we do also have authorities as being the representatives of how the different similar actors would reason in order to actually make a push for a more transparent and resilient supply chain. Besides that, we also have technical tech providers of different kinds. We do have the tower providers and also additional service providers. So let us then move over to run a video that is visualizing the vision of VWT.
Watchtower Network, the VWT, is a solution designed to raise visibility in end-to-end supply chains. As a cargo owner-driven port-centric partnership, the Virtual Watchtower is a machine-powered solution to secure on-time deliveries of orders to customers all over the world. Here's an example of how it works. 10 containers from Northern Forest destined for Australia have been shipped by rail to Oulu in Finland, where they are loaded onto the feeder ship Hara 5. Cargo is exposed to risks. Ideally, all the parties concerned can monitor the merchandise moving from origin to destination. Hara 5 has lost some time in a storm. The ship's Global Fleet Operations Centre in Copenhagen is updated on the situation. If they stick to the original plan, many containers will miss their connection at Zeebrugge. The captain of the Hara 5 and the operations centre collaboratively assess the situation, and the captain decides to follow the machine-powered VWT recommendation and increase the ship's passage speed to make the planned arrival time. On arrival at Zeebrugge, the personnel in the port's control room monitor the reloading of the 10 containers onto the Blue Ocean, the ship that will deliver the cargo to Sydney via Singapore. An update on the successful port visit is delivered to the operations centre in Copenhagen and in turn to the ports and each cargo owner. On the way to Singapore, a new incident emerges, a potential wait and delay in the Suez Canal. The VWT immediately identifies the cargo and the affected cargo owners. The VWT flags and alerts the potentially impacted parties. In a virtual situation room hosted in the VWT, the network's members from different organizations and places across the globe discuss the incident instantly based on analysis provided by the VWT. On this occasion, an update arrives that the situation has been resolved. After an on-time arrival in Singapore, the Blue Ocean's reloading of cargo has been monitored and shared with all parties involved, thanks to the VWT. The ship is on schedule for its destination, Sydney. Whether your cargo travels by sea, land, or air, the VWT is a new way of ensuring sustainable, safe, secure, and on-time transport. We thank our partners for supporting the Virtual Watchtower project. Contact RISE or A-star IHPC if you're interested to join.
So there are two things that drives us when we are doing this and building the Watchtower initiative. First of all, we believe in the idea that we could construct something that is conceived as a public good, that is providing public benefits. And that is the approach that we are taking in order to both adopt a balanced approach to economical and societal value creation. You could picture this as a lighthouse that is something that can be consumed by everyone, and that has been constructed in order to allow everyone to, in the lighthouse case, to navigate safely. And the other thing is the KPI triangle, where we believe that you need to also take a balanced approach between delivery precision, transport cost, and sustainability. And importantly here is that you should conceive VWT as a distributed way of data sharing. And just to mark that, so everybody has the same conception of VWT, is that picture a network of virtual watchtowers that is connected to VWTnet, where each node is the physical node that is engaged in the specific shipment of the shipper, and those are then to share data between each other. So, having said this, why would we then be doing this? We believe strongly that the approach that is taken by in the VWT, with having the national research institutes taking the role as coordinating this effort, is very unique. We have Research Institute of Sweden that took an initiative together with A-Star in Singapore, two research institutes that are governed by the states or the governments, and they have a role of empowering the competitiveness of the industry in the respective country. And what happened is when we started to explore this collaboration is that we also managed to bring competitors into the same arena of bringing something that is of higher value than each of the individual actors could do. At RISE, we do have the belief in that you can have and gain common situational awareness based on multiple data sources. We will see in the demonstration that different data sources are providing different insights of the supply chain. We need to bring those together. And that has been done in something called the CDM approach, the collaborative decision-making approach, which we at RISE has been pushing a lot. In A-Star, we have a lot of experience, or they have a lot of experience in empowering the intelligence by AI and big data analytics. In VTT, who is the Finnish equivalent to RISE and A-Star, do have a lot of experience from environmental, or looking into environmental concerns, and also later we have been joined by TalTech, the Estonian equivalents to RISE, A-Star, and VTT. So let's hear from Suchu Fu, that is the director of the AI research program. Go ahead, Suchu.
Good morning and good afternoon, everyone. I'm Suju from Institute of Health Computing, A-Star, Singapore. On behalf of the IHPC team, I would like to express our gratitude to all our partners, especially the Research Institute of Sweden, RISE, and many others, for their collaboration on this meaningful watchtower research project. We would also like to extend our thanks to the Singapore Maritime Institute for supporting the Singapore research team in this joint effort. The VWT project aims to develop innovative methods to enhance visibility across the end-to-end supply chain by leveraging data sharing, big data analytics, and AI techniques. Later in the session, my colleague, Dr. Yin Xiaofeng, will provide more insights into our AI research and its role in optimizing supply chain. Stay tuned for more sharing from the joint VWT team. Thank you and enjoy.
Thanks a lot, Suchu. And let's move over to one of our shippers, Stora Enso. Stefan.
Good morning.
Yes, thank you. Can you hear me?
Yes.
Thank you. So my name is Stefan Vere. I'm here representing Stora Enso and our view on why shippers are in need of a higher visibility on the progress of shipments. As we see it, The VWT is about improving our ability as cargo owners to essentially take better decisions by bridging the information gap in the supply chain today. In the complex and volatile global supply chains, a large degree of decisions for us as well are both reactionary as well as taken with inadequate information. By mitigating this, decisions can be increasingly more proactive, faster, as well as agile, and rely less on personal preference and instead supported by data. Essentially, we believe that it's about keeping our promise to our customers, not necessarily by always keeping confirmed delivery schedules, but by realizing that it is seldom the delay in itself which causes the most harm, but rather the lack of up-to-date information, and thus the inability to set proper expectations further down the value chain. Thank you.
Thanks a lot, Stefan. How about you, Daniel, at Alleima? What experience do you face?
Hello, Daniel Storm from Alleima. Yeah, and for us, it's basically reliability that is important. Both the schedule reliability and that we can trust the update in time when things happen. I guess we all have experienced tough situation, especially for the sea freight during COVID and the block in the Suez Channel, and now due to the situation in the Red Sea. And when it divides and we get, for instance, port congestions, it is extremely important to be able to share new plans and new actual events. This has been hard in the setup we have today. And our customers and also our own production abroad are really depending on reliable information, and we need to be able to give them that, basically to keep our customers happy. Thank you.
Thanks a lot, Daniel. And another shipper and being a freight forwarder, acting on behalf of one of our partners is Bertling and Matilda.
Yeah. Hello, thank you, Michael. Hi, everyone. I would say for us as freight forwarders, the whole thing with primary data sharing is a game changer. Because it would enable us to retrieve quicker and more accurate information to enable better decision making, which would lead us to be working more proactively rather than reactively, which is key in today's environment. And quick and reliable data in one neutral network as VWT would help us to achieve more precise and targeted actions when we face disruptions in the logistics chain, as we often do. So we need every piece of information that we can get. And I would say, especially today, efficient data sharing is a necessity to tackle the challenges that we have at hand. And ultimately, by sharing primary data with one another, we're building together a more resilient network, which is what most people would want, I suppose. It's been great to be part of the VWT, and for us, this whole thing with primary data sharing is really something we believe in and appreciate. So thank you.
Thanks a lot, Matilda. And just to add on to the desires that the shippers have, I would also like to bring Morten Sundell from H&M, who is also a partner of VWT.
Yeah, hi all. My name is Morten Sundell, and I'm the Logistics Innovation Manager at H&M. And just like much of what Stefan from Stora Enso and the previous speakers mentioned, as a global shipper, we are affected by the dynamic world situation as of today. And to avoid problems, we strive to have pre-alerts and early warnings on incidents in the shipping routes, which is not always easy as of today. But going into this, as an early adopter, we were clear we wanted to help develop solutions that solve real problems. And we hope for the virtual watchtower community to build a platform of collaboration to boost innovation, sustainability, and resilience. And in this, having a wide network of strong partners, we think can significantly increase the chances of adoption, making this big and like the standard. Furthermore, we believe that the collaborative network and data sharing, I think just like Matilda mentioned before, it can extend our insights and support us in adapting to a situation before it becomes a problem, and long-term make better proactive decisions. So we are really looking forward to what this develops to. Thank you, Michael.
Thank you, Morten. Very sorry. Here are you. I forgot to shift the slide.
Yeah, I'm on the camera, so I guess it's fine. Thanks.
But I just wait a little bit here so that here is Morten Sundell information now. Okay, thanks a lot, Morten. So what is all this? And we have three components that I would like to highlight here. First of all, we believed highly in that we could utilize the contractual forces to encourage digital data sharing, and this was something that Stefan, Vere, and ourselves talked a lot about in the beginning. What if we had a power of attorney that actually qualifies the different actors to share data between each other issued by the shipper? So this was one key component. The second one is the itinerary. And think about it as if you're a passenger that you are traveling, you would have an itinerary of the taxi picking you up, the flight ticket, the hotel visit, etc. And we believe that we can do the same thing with the cargo movement, because the problem may not just rely on that we are not just in time to a certain transport node. It is that the connections in or at the transport nodes that actually are working, so or are being done as smooth as possible. So in the itinerary, we share or extract or make sure that data from primary data sources concerning planned, estimated, actual time of arrivals and departures along the end-to-end chain is being compiled in one itinerary for the specific shipment. And this seems to be the foundation which you can do a lot of analytics and tailor different aspects associated to that shipment if we just have the itinerary with report from the primary data source. And what we then did was that we said that let us see if we can explore two use cases from the beginning. And the first one was disruption management based on this visibility, meaning that is there a strong deviation from the plan time that we anticipated from the beginning in relation to what is actually the anticipated actual outcome or the estimation. Then we have an alert, which means that we need to handle this in a certain procedure. And we will see in the demonstration that there's a lot of things that can go on or happen that is actually at the end of the day or at the end of the transport actually not responding to the original agreements that the BCO made with the end customer. This initiative, again, is about data of shipments shared directly from the primary source of data. The second use case, which we will come back a little bit to later on, is emission calculations, which we also believe that is something that needs to be catered for, and that is also requiring the holistic view of what is happening throughout the chain as well. And this is something that is an emerging concern for many shippers as well. So let's see if we can now dig into the technical architecture that has been set up to pilot VWTnet. And I would like to first introduce Per here, to Per Löfbom from RISE, to actually to have a look and a deeper look into this. And he will be accompanied by Jens Lund Nielsen and also Jose Cantera from IOTA, which is the technical architecture that we are building upon. So over to you, Per.
Thank you. Thank you. What we've been doing here is piloting the solution that we showcased in the conceptual demo in Singapore Maritime Week 2024 and tied these virtual watchtower into a distributed network. What we aim to in the architectural significant requirements are to have a federated network of VWTs sharing a single version of the truth, should be self-organizing. The VWTnet should also contain a comprehensive distributed registry of all VWTs, participants, and services exposed. It should be based on a distributed architecture with no central database, distributed storage, no central infrastructure, no central control, globally scalable, open source. And what's also very important in these open sharing data environments is to ensure data integrity and sovereignty. So the data stays with the authorized participants. And what we are aiming for in the use cases we have now with disruption management and emission control is sharing only minimalistic data sets with predetermined parties. And the message pattern should be event-driven. So that's the core architectural significant requirements we had from the beginning when choosing a technical architecture for this. So now I will leave over to Jens Lund Nielsen, Head of Global Trade and Supply Chains of IOTA. So please, Jens, take us through.
Yeah, thank you, Per. So a background, I'm going to tell you a little bit about who the IOTA Foundation is and how we enable this in supply chain. My own background is working 10 years for Maersk and then 6 years for the IOTA Foundation, and I always focusing on trade facilitation efforts. So a little bit about the IOTA Foundation. We are a non-for-profit organization and we are registered in Germany. We were founded with the mission to drive the adaptation of distributed ledger technology, or blockchain often called, and we are at the forefront of this technology innovation. We've been part of revolutionizing the way we think about and implement blockchain. And unlike traditional blockchain systems, we offer a scalable, low energy, low cost, and decentralized platform that is really designed to facilitate data transfer and secure transactions. And our core focus has been on addressing real-world challenges. And one of the most critical areas that we are tackling is trade and supply chain solutions. So in this globalized world we live in today, the efficiency and transparency of supply chains have become paramount, and traditional supply chain systems are plagued with inefficiencies, high cost, and the lack of transparency. And this is where we are hoping to step in and offer an innovative solution. The technology we have enables real-time tracking and verification of goods, enhanced transparency and trust across the supply chain. From the product line to the end consumer, every step of the journey can be securely recorded and verified, and ensuring the authenticity and integrity of products and shipments. And this not only reduces fraud and counterfeiting, but also optimizes the logistics and reduces operational cost. So our background is that we've been working with governments in East Africa and in the United Kingdom, where we developed an infrastructure with features for international trade, such as digital identity, authenticity and authority of data, and value transfer. The aim has been to connect existing data systems for ecosystem collaboration in a distributed format. For example, it is now possible for every Kenyan company to use this technology to go and fetch their export declarations, their phytosanitary certificates of origin, and so on in the different government systems in Kenya, and make them available for their partners, which is transporters, importers, destination countries, and so on, as trusted, verifiable data. So I'd like to highlight that we have used this to establish a twin foundation, that we have accepted that no single or privately owned company should own such an infrastructure, and therefore we have established a twin foundation together with the World Economic Forum, the Global Alliance for Trade Facilitation, Trademark Africa, the Chartered Institute of Export and International Trade in UK, and the Tony Blair Institute for Global Change. So with these partners, we want to provide a neutral digital infrastructure and public good infrastructure that is open source and available both to government and industry. So the Twin Foundation actually aims to bring together industry leaders, policymakers, technology experts to drive this adoption of the solution and create a sustainable ecosystem. And in the dialogues we had with the Virtual Watchtower Network, we realized that our vision and goals very much overlap. And therefore, we decided to support the VWT with the use of the twin technology. And this way, we hope to accelerate both VWT and its mission, as well as continually testing and improving the technology we're developing in the foundation. You can go and read a little bit more about us on twin.org. And as I conclude, I'd like to emphasize the transformative potential of our work and collaboration. I'd like to hand over to Jose, my colleague here, who is our lead architect for Twin, to explain a little bit more about how the technology is being used and piloted for the VWTnet. So I look forward to continue our collaboration and work together to make supply chains more efficient, transparent, and secure. So Jose, handing over to you.
Thank you, Jens. I'm going to explain to you in a very condensed way, I would say, what is our proposition from a technical and architectural point of view around Twin. As Jens has mentioned, the main problem we want to solve is how these different actors in the supply and value chains, they can exchange data, they can share data. And first of all, we need to understand that we don't want to be revolutionary in the sense that we are not telling you you need to drop out all your existing systems. All the opposite. Your existing systems and your current investment must remain and can remain. And what we are offering you is the capability of these existing systems that they can share and exchange data among them. And the vehicle to do that is the Twin node. So different Twin nodes can exchange data among them and can exchange data with your existing systems. And this is done through, first of all, adapters. You need an adapter from your existing system to a Twin node. And of course, there is a data space connector that is connecting each Twin node, exchanging data. This data can be exchanged on a pool basis. So one Twin node may ask data from another Twin node, or there can be a push. So every time something of interest is happening, it's known by a Twin node, can be propagated to other Twin nodes. But of course, you might be wondering how the different actors know each other, etc., etc. And this is where it comes the distributed ledger infrastructure. So part of the Twin node is the distributed ledger infrastructure, the distributed ledger that it is provided by IOTA, and it implies that the participants, they register themselves. So there is no a central authority for registration. They can register themselves. They can have a decentralized identity and let know other participants that they are in the ecosystem and what are the services they are offering. So the data exchange services they are offering to other participants, and this is where it comes the catalog. So, but these participants, in order to participate, they need to go through a compliance mechanism, and that compliance mechanism ends up in the issuance of verifiable credentials. So once you have your verifiable credentials, for you as a participant and for your services, you can collaborate with other participants. And this is where, each Twin node might be might be connected to different to a virtual watchtower, and all the information that these virtual watchtowers can be exchanged with other virtual watchtowers through the infrastructure. And an important point to note is that this architectural setup is intended to interoperate with Gaia-X, that it is the data space architecture, reference architecture that is being developed in Europe. And of course, all these exchanges of data among the different participants, it's important to note that it is properly notarized, it is properly audited, thanks to the ledger infrastructure that we are basing the architecture on. So that's an important point. And last but not least, of course, the data exchange only can happen if the actors have the proper permissions. So you can imagine that from the power of attorney, you can translate that into, I would say, machine-readable representations that are permissions that essentially grant the right to get the data from one actor to another actor. So by default, of course, actors are not going, so the data is going to remain at their nodes, but whenever they publish new permissions, they publish new service to the catalog, other actors might discover them and then query the data on a need basis. So this is essentially the architecture. So three points: that you don't need to rebuild your existing systems. You just need to develop adapters. You can deploy your node, that node through the connector, the data space connector, exchange data with other nodes. And for being a participant, you need to be registered. You need to be clear so that you can appear on the catalog, and that implies having a decentralized identity others can know through the ledger infrastructure. So this is the summary on a high-level basis of the architecture, but Per is going to deep dive a little bit in context of the specific virtual watchtower case. So thank you. Now handing over.
Thank you, Jose. Yes, and how did we do the setup for VWTnet in the prototype? Well, we have virtual watchtowers. In this case, we have Transporeon that has one virtual watchtower. We have Roby that has another virtual watchtower. And we can, of course, have more virtual watchtowers. These virtual watchtowers connect to one of these twin nodes to publish and consume shipment data. And also to share data between them through the twin data space connector. So that's one setup that we have. There's also the other possibility that companies, of course, can connect directly to a twin node to publish and consume shipment data, and also, of course, query for VWT services and participants and register VWT services and participants. But it requires, of course, to comply with the APIs that are exposed from the twin nodes, mapping between local APIs and the twin node APIs, and also mapping between formats, payload formats. Right now, we're using the transport collaboration messaging format as the canonical format when exchanging messages between virtual watchtowers. I think that's, yeah, let's take the next slide. The message routing, then, you can wonder how does the message routing work? Well, this relates to a mechanism that's governing how messages can be routed to different participants in a shipment. And of course, you need to be granted permission to read or modify or possibly federate permissions to data in a shipment. And that's done through a service description. So you can, as a shipment participant, you can define or register your service globally, which is then globally accessible throughout the twin network, all the VWTnet, or you can do it in a local node, just one VWT tower or one twin node that will just make your service consumption within that. What we use is open digital rights language policies accompanying a service registration, where you can set the actions and activities allowed for shipments or parts thereof for distributed identities. And we can also notify participants of messages being sent or put on the ledger using webhooks or subscriptions. Next slide, please. The onboarding process, that's mainly, I would say it's two parts. First of all, every participant in a shipment needs to only one time, register a distributed identity. That's the green parts here. And this could be done directly by the organization or the company joining, or it could be done by a virtual watchtower watchtower on behalf of the organization, since they know their customers, or KYC, as it says here. So the virtual watchtowers can be identity service providers, registering decentralized identities on behalf of their connected organizations. So that's what everyone needs to do once at least. You can be a global participant, receiving a verified credential, and then you go through the process in the yellow part here, where you present credentials like you need to comply with terms and agreement of VWTnet. You need to present your legal entity identification and your legal registration number, and then you will receive a verified credential and be registered in the twin catalog, the global catalog, discoverable for everyone. Or you can do a local. You can just be a local participant in one of these twin nodes, which is much simpler. And then you will just show up in the local twin catalog. It will not be globally searchable or discoverable just within a twin node. So that's the different ways of registering. And of course, you can promote local distributed identities to global recognized participants as well. Yeah, that concludes my part. Thank you. You're muted, Michael.
Thanks a lot, Per. Now we have digged into the technical details. We have heard what the desires are, and so let us now visit what this gives us in practice. Just to emphasize that we have at the moment, I think it is 157 shipments that VWT has monitored or is doing the monitoring of using this type of distributing data in different ways. And we have picked one shipment that we will now follow in the demo, and the demo will be pursued by Transporeon, A-Star, Marine Benchmark, Romby, and also will be commented upon by Rice, and also commented by Daniel from Alleima, as the shipment that we're looking at is an Alleima shipment. So I hand over to Serge Samshulan from Transporeon to start the introduction.
Yeah, if I get unmuted, and it worked out. Good morning, good afternoon, good evening, whatever is appropriate for our participants. Pretty exactly 1 year ago, Transporeon's watchtower was awarded by ALICE, the Alliance for Logistics Innovation through Collaboration, with the award for supply chain data sharing. In parallel, we agreed with the virtual watchtower community to join, which is a perfect match. One thing comes to the other. Data to come to data is not so easy. And we heard it already today. We will hear it again and again. Everybody is happy with data sharing unless he's expected to share his own data. Virtual watchtower is a super important initiative to get that hurdle sorted and moving the industry forward to interconnect with each other. So we are more than proud to be part of that and more than happy to support. And let me introduce my colleague, Mark Scherling, a full-blown ocean expert as we speak. And he was part of developing that Transporeon watchtower. So over to you, Mark.
No, good morning all. Thank you, Serge, for the introduction. Indeed, my name is Mark Scherling, part of the team at Transporeon of Serge, where we stand for the data partnerships and on data sharing for ocean milestones, but in a larger context to anything which has to do with transport. I also had the pleasure of presenting prototype 1 in Singapore on behalf of Virtual Watchtower earlier this year. But now let's go and make it a little bit more practical. We go from theory to practice now, and let's have a look on what it actually looks like or what we provide as Transporeon within the VWT. Well, Transporeon, I think, well, for many of your players, we are a known company. In this aspect, we, as Virtual Watchtower, we provide transport and logistics information and data on shipments within the virtual Watchtower context, but we also have the intention not only to provide and share data in there, but also to consume data in there, and truly be one of the nodes that's working bi-directional within the VWTnet and the VWT community. As such, we have selected one shipment, and here we are acting as a watchtower for Alleima, one of the partners in VWTnet. And we've selected here a shipment MSN with an MSNU container. What is already interesting is through the monitoring and the tracking that we've done, we already see that there is a delay of about 20 days that's being incurred. 20 delays is is an important delay, but still, with having this information, we provide shippers with actionable insights on their actual shipments. If we visualize this a little bit more, we see that we have a shipment coming from Zalvigny that is destined for Mundra in India, where we have already collected a number of timestamps. The cargo has been, so the container has left the depot, it has been loaded, it has been brought back into the port of Gavle, where it shipped on the first vessel heading into Le Havre. In Le Havre, it transshipped on the current vessel with which it is sailing, the MSC Aquarius, which is sailing to its destination here on Mundra. Of course, with the current unrest and socioeconomic impacts, you know that we are no longer sailing through Suez Canal, but these days we take the long route around the Cape. What is interesting is that it is already on our level consolidated data that you have. You have information from the shippers, shipping lines, satellites, and so much more. This already resulted in a number of alerts, because by consolidating data, and that's exactly also what the VWTnet is doing, and we are just one of these nodes providing data in there, is yes, we collected some information at the start as provided by the shipper. And here you see also that shipping lines, they are providing us with information on transshipment, changing of vessels from one to the other, which is then of course every time impacting final delivery and the estimated arrival of the vessels. Other partners in VWTnet will add other information to the shipments that we will also be happy to consume. It will be information on pre-carriage and on-carriage provided by Rombi. We will see Marine Benchmark providing us with information on weather and weather impact. All this information will then be consolidated within VWTnet and put at disposal at the different players and actors. With this, I happily hand over to our next partner in the VWTnet. Michael, you are master of ceremony.
Thanks a lot, Mark. And let me move over to Xiaofeng from A-Star, IHPC, to show what can be achieved with access to the VWTnet data by demonstrating an analytics service.
Yeah, thanks, Michael. Good day, everyone. I'm Xiaofeng from A-Star's IHPC. Today, I'm going to demonstrate the capability of the VWTnet through exposing some of the analytic services we developed and how we are able to utilize the shared information through the VWTnet. So the web page you are watching right now is a VWT connector we developed that is used to retrieve and consume the relevant information from the VWTnet. Just now, the information of this particular shipment is shared by the Transporeon to us. So their logistic technology providers have already provide us with the planned arrival, estimated arrival. Over here, what we do is we try to combine with the vessel information locally and try to come out with the predicted arrival over here. And from there, the predicted arrival will be pushed back to the VWTnet to be consumed either by other VWTnet users. So when we have this vessel information, because this is piece of information that is necessary for our analytic services, we're able to come out to call the backend services to get the predicted ETA. For example, it is over here. Hopefully, it is more accurate than the planned or estimated from the other service providers over here. Of course, you may notice One thing that the destination port Monja is actually highlighted over here. This is due to additional disruption events flagged by the VWTnet. When we retrieve the information, it shows that the destination port has something happening. There's a potential dock workers strike over here. We have a link to the piece of reports. There's a strike, a potential strike over there across ports in India, starting on 17 November. Prior to the vessel's arrival at Port Monja. This link brings us to the source of the reports and also highlights the needs to raise awareness of the potential human disruptions and delays if our ship is sailing over to the India ports. And we have to monitor the situation closely and prepare appropriate mitigation plans over here. And another thing I want to show is some of our backend services over here. We are actually linked to the VWTnet. The services is able to simulate a terminal operator, a cargo owner system, or some of the analytic services. So we are showing over here. We briefly explore the VWT analytic services. We receive all these messages over here. And also requests from this VWTnet, such as this ETA predictions and poaching predictions, and also support resilience analysis. It is through the connector just now we show. We develop that consumes the data from the VWT and get the information, necessary information from there. Then eventually we are going to push back the information we come out from our analytic services to that particular VWT nodes request for the information over here. Yeah. So basically, VWTnet aims to improve supply chain feasibilities and accuracy to eventually enable stakeholders to access a single source of truth. To achieve this, we'd like to encourage federated service partners on board VWTnet so that we can more data analytics based on more feasibility of the shared data. Please reach out to us, RISE or A-Star or VTT for our further collaboration. So now I will hand this screen back to Michael or Torbjørn from Marine Benchmark.
Thanks a lot, Feng. And now I hand over to Torbjørn. Let's see what kind of intelligence you can dig out of this specific shipment as well.
Hey, thank you, Michael. I'm Torbjørn Rydberg, CEO of Marine Benchmark. And at Marine Benchmark, we focus on the analytics on vessel operation. And we collect AIS data and combined with weather and sea status, port calls, and we have historic voyages since 2009 from our supplier, Standard & Poor's. So look at MSC Aquarius, which is the current position outside Senegal. And when we look at the track of a ship, we can see, as shown before, started in Europe. And using the AIS message, it actually say from the ship via AIS, the next port of call is Port Louis. And the ETA is 22nd December, 1700 UTC. And most likely from there up to Mundra in India. What I would like to demonstrate here is how the ship actually will face the weather. So here is the weather situation with wind and wind strength. And 6-hour steps, we can move the ship forward and also move the time forward. You see in the time slider, the time, like here, and the ship position moves and also the weather moves. I can speed this up to 24-hour slots and we see the coming days, how it will look like. And sometimes this time of the year, there will be heavy weather south of South Africa. But in this case, the heavy weather is further south, so we cannot see any problem with the weather in the coming days. So here it's looking good, and we can say that it most likely will handle the time. So going back to now position, instead of wind, we can also show the wave situation with the very dark down here, for example, is more than 8 meters significant wave height. And then in a similar way, we can move the ship in the coming days going forward, and we see how the heavy sea is far from the coast, and the shipping will work south of Africa. So I think this is what I have at this moment.
Thanks a lot, Torbjörn. And let me move back to my screen. I now introduce Vidya and Per to make a short presentation about the onboarding.
Yes, please, Vidya, take us through the partner registration mock-up we have here.
Thank you, Per. What we really envision through this, and I see some questions in the chat, in how very localized small operators, either from a terminal or from a first mile, last mile movement, can enter information into VWT. What we're going to build is a very lightweight user interface that can be provided to then enable people to enter information relevant to what information they have, but they can see the entire ecosystem. So what you're seeing here is sort of a roadmap that says, first, you've got to identify your credentials, come into the VWT network, log in, create an account. Can we go to the next slide, Per? And this is very contextual. So if you're a first mile transporter and you're moving, a container to the port, you'll only see the containers or information relevant to you. And it could be to when the port expects it or when the port will discharge it. So it's very contextual from that perspective. And if we go to the next slide, we'll see the context here. So this is, a slide that talks about a transporter coming in and saying, this is when I'll pick it up. This is where it's going. And whatever information I have, I can put this in. So a carrier can say, what is my pickup point? What's my delivery point? And this goes into that ledger that we talked about before. And the next slide. And this is an example where we could have terminals not completely integrated, but they could talk about when a berth is available, when they could receive a container, when a container would actually be received, and when it was when it was supposed to be received and was actually received. The reason for this information being important, where everybody feeds this information in a very simple UI, is then it ties into what we talked about in the very beginning, which is the ETA. How does it affect the entire ecosystem of where things are? So what we wanted to highlight really here is a very lightweight UI where you can come in and manually input information. We also have the integration that was talked about, but this is tying in the loose ends that we really wanted to. So we just wanted to talk about saying how information is going into VWT at the very lowest level, which is manual entry. Thanks, Per.
Thank you.
Thanks a lot, Vidya and Per. And this is really showing how we can manage an organic growth of the VWTnet based on the specific shipments that the shippers have provided to VWT. Daniel, just going back to Alleima, does it provide you any added value?
Yeah, of course. I mean, it feels like I repeat myself, but to use these several different information sources within this network, we will be able to make a right decision. We have this real-time, reliable information, so to say. And I mean, of course, we're not blind today. We have part of this information, but this will help us to have a better way to synchronize the expected outcome. And I mean, just like both Matilda and Morten talked about earlier, this will help us to be able to act before it becomes a problem, a real problem for us. So I think that the gaps that we have today, I think that Virtual Watchtower can be a good complement, and if we add on to the sustainable perspective as well, then I'm really looking forward to see what this can get us in the long term.
Thanks a lot, Daniel, and very happy to hear this. Now I will move over to Kenneth, who will just visualize how it all works in a very efficient visualization that has been generated for this session. So please, Kenneth, over to you.
Thanks a lot, Michael. My name is Kenneth Lind, and I'm from RISE. Yeah, we have an animation that I will try to show real quick. It's based on the same shipment that we have used earlier in the session. And at the top, you see the physical transport. To the left, you see VWTnet with actors inside connected to VWTnet and also outside of VWTnet. And to the right, we have the itinerary, as Michael talked about in the beginning, and that we will populate along the transport chain. And you see that the different actors, they are connected to VWTnet, the distributed ledger, with their own towers. And towers could be transport management systems, but it could also be very simple applications, as we have seen. So we will go through what happens when planning the transport and what happens during the transport, sharing data through the distributed ledger and populating the itinerary. And the data concerns planned, estimated actual data for arrivals and departures along the end-to-end chain. And I will go through here what happens during planning phase. So here the cargo owner to the left and the end customer discusses the transport assignment. They plan the transport, and you see 3 transport nodes involved and 4 transport carriers that are involved. One of the carriers are currently not connected to VWTnet. The shipment ID gets defined, and the shipper can reach out to the actor not connected to VWTnet and onboard that actor. And then the shipment details is sent out and negotiated, and the planning can go on with the planned times of arrival and departures along the end-to-end chain. So that concludes the planning phase. And you have this in the itinerary, as you see. So then we move into the in-progress execution phase of the transport. Here we have an early estimate from the carrier that is supposed to pick up the cargo at the point of departure. And you see it's populated into the itinerary, and it's shared with the shipper. Then we have ETAs and ETDs for Port of Gävle, which is the first transport node. That is being shared with the shipper and the transport node by the carrier. Then the actual transport is ongoing. An actual time of departure from Sandviken is shared with the shipper. The cargo arrives at Port of Gävle, the first transport node, and the data regarding that is shared with the shipper and with the next carrier. The carrier that is supposed to pick up the cargo at the next port, which is Le Havre, is sharing an ETA with Le Havre and also with the shipper, providing a heads up. This is where A-Star consuming the data in the itinerary and provides a new ETA to Mundra, which is later on in the transport, to the shipper. And then the transport goes on to Le Havre and so on, and the concerned actors are informed about this. So as you see, and this goes on along the complete transport chain, and you see that we are sharing data with the shipper and the other concerned actors in the transport, and the itinerary is populated at the same time. So I think these are the main key features regarding data sharing along the transport. And I know we are a bit behind schedule, so I think I will stop there and leave it over to Michael. Thank you.
Thanks a lot. And just to emphasize now that up to this point, we have used shared primary data on plans, estimate, and progress on arrival and departures to and from nodes to monitor the shipment in the end-to-end chain. Just to a minute exploration, Torbjörn, can you show what else can be visualized if you take a shipper perspective?
Yes, I will do. So just looking at my screen, I have now opened up the vessels where Alleima has cargo on. And I would like to go in and select one vessel, which is MSC Sweden. And looking at this vessel, we actually have the estimated time of arrival, which we can look up here. So from AIS, it's saying 15 December 1700. And in a similar way as I did for the last one, we can actually go forward and move the vessel in the weather going forward. And Atlantic this time of year is a bit heavy. However, looking at the historic track of this particular vessel, we can see how the ship actually has made the voyages, and it's currently 2,600 nautical miles from here to New York, New Jersey, and that is an average speed on just below 17 knots. So the AIS time is likely to actually happen. It's possible. So I think that was a very, very quick look at this one. Hand over.
So now I go back to my screen again, and I will, let's see if I can do it. Oh, you see my screen, I hope. So I will move over to, sorry, I'm skipping. There we go. So let us now have a look on the outlook here, and this will be part of the session here will be done by us from RISE and also from University of Gothenburg. So first of all, now we are concluding phase number 1 of the VWT initiative, initiated, as we said, during Singapore Maritime Week 2023, building on the collaborative agreement signed between RISE and the Singapore Maritime Institute. And this 2-year endeavor is now providing us foundations for taking VWT into the next phase. We will shortly hear from Trisha and Abhinayan about the organizational setup, which will be a trust combined with a DAO, realizing this idea of that everyone is contributing to with public benefits. We have defined value propositions for users in the VWT community. We have reached the target of a VWT community of 50 members, and we are also prototyping and piloting the solution. We hope that we can establish a membership-based organization that is by the use of donations and membership fees can run this public good as we have been talking about. So what I would like to do first now is to introduce Trisha and Abhinayan from Gothenburg University to provide some insights of the organizational structure that we are thinking about.
Thank you, Michael, for offering us the floor. Hi, everyone. I am Abhinayan. Trisha and I, both from University of Gothenburg, will briefly touch upon the institutional innovation in VWT. Many speakers have already highlighted that making actors share data in an ecosystem is a challenge. And we have seen that in VWT as well. We have participated in all the living labs, and it has been reiterated there again and again. Our research found that impersonal structures are important for actors to share data because impersonal structures promote trust. So to overcome the challenge of data sharing and promoting trust, we did 4 things. First is that we classified value in VWT as both economic and societal. We defined VWTnet to be open source, open standard, and public good. We categorized the actors into 3 types, mainly users, for example, carriers, shippers, freight forwarders, and ports. Second is developers, that is the technology providers. And third are non-profit organizations. So examples are research institutes and universities. And fourthly, what we did was to propose a 2-tier structure that you have in front of you, which comprise a charity and a DAO, that is a decentralized autonomous organization. Now, the 2-tier structure is significant because of 2 reasons. First, it makes shared governance achievable at a reasonable cost. Now, ecosystems do not go for shared governance because it's expensive, but with blockchain, it's possible to have it at a reasonable cost. And the complementarity of the charity and the DAO is the second feature that you need to focus on in this diagram. For you, the charity promotes public benefit and the DAO promotes collective decision making. So what we have done is highlighted charity, DAO, public benefit, and collective decision making in yellow on the slide in front of you, just to lay emphasis on these 4 terms. And now I will pass the floor to Trisha to briefly say a few words.
Yes, thank you, Abhinayan. So I will summarize very briefly. So the structure leads to 5 design principles for VWT. Sustainability is a binder. Institutional and technological innovation walks hand in hand. Shared governance is important to build trust. Public benefit and collective decision-making are important for shared governance. Non-profit organizations instill legitimacy and openness. So once the 2-tier structure is operationalized, we hope to see the emergence of collective decision-making laboratory, CDM lab, for transport where innovation happens. So with that, thank you for your attention, and we would be very happy to answer any questions that you have in the chat. And of course, you're very welcome to contact us also by email. All right, Mikhail, thank you. Back to you.
Thanks a lot, both Trisha and Abhinayan. And let's now move over to as a first comment also from TalTech, our latest research institute type of body joining us. Ulla.
Hello, good morning. My name is Ulla Tapainen. I'm a professor of maritime transport in Estonian Maritime Academy, Tallinn University of Technology. And we are very excited to be part of this group as we are our studies in the institute and in our research group are especially for the decarbonization and operational efficiencies. We are both focusing on vessel side and the port side. And here on my slide, you can see a very new, just established a year ago, Estonian Maritime Cluster. So in addition to us and our researchers, we are also, bringing along our network in Estonia. And of course, we try to get as many of them as possible to be part of the group, but at least them to know where we are heading in this. And some of these companies are, of course, not only Estonian, but working worldwide, or at least in European wide. Thank you. Michael, you are muted.
Very sorry. Thanks a lot, Ulla. And just before we're coming into the Q&A session, I would like to hear from you, Kenneth, on standards. Do you have any comment on how we are adopting standards?
Yes, thank you, Michael. So today we have shown where we stand on VWTnet and the key features of VWTnet connected to disruption management and how different actors can provide data and insights regarding a particular shipment. When we go forward now and prepare and implement an operational setup for VWT, we will build on available relevant standards and secure that those are possible to feed data to VWTnet by mapping these to the used format that we are using, building up the distributed ledger and the itinerary, as we have seen. So thank you, Michael.
Thanks a lot, Kenneth. And Per, we are talking about a shout-out function. Maybe you would like to comment on that as well.
Shout-out function is the function to include temporary participants in a shipment, which is important because you as a shipper don't actually know all the participants in the shipment in beforehand, maybe. So we need a function for handling this, and part of that is what Vidya showed you in the demo, the mock-up we have. So that's the function we will continue elaborating on and implementing in VWTnet. So that's where we are in regards to that.
Very good. Thanks a lot, Per. And of course, what you have seen now, just to emphasize that the itinerary makes the foundation for reasoning around the shipment, and that it needs to, of course, be populated as much as possible with the data from the primary sources, and then we can make a lot of intelligence in relation to that itinerary, such as, for example, also CO2 emissions. That is also now being elaborated on which data that should be shared when it comes to the emissions that is affecting or affected from the specific shipments that we are doing. So what I will now like to do is to hand over to Wolfgang for part number 5, the questions and answer session here. And Wolfgang, I hand over to you.
Thank you very much, Michael. And the Q&A part is always a possibility to give feedback, pass your remarks, and of course raise questions. And we have some people that wanted to make some remarks, and the first is Timo Mandabaka. He is research team leader at VTT, and as you now know, VTT is one of the research institutes backing the initiative. Timo, please.
IT Technical Research Center of Finland is proud to support initiatives that harness technological progress and data utilization, fostering collaboration for the benefit of global well-being. Maritime transportation is crucial for global and Finnish well-being and industry. For Finland, which is essentially an island in terms of transportation, the challenges of yearly ice coverage and shallow waters make safe navigation particularly demanding. Ensuring resilience, security of supply, and sustainable maritime operations is of utmost importance. We are honored that the Nordic countries and the entire virtual watchtower community are contributing to greater transparency in global supply chains and essentially the security of supply in a sustainable manner.
Thank you very much, Timo, for this remark. And yeah, we are very thrilled by having such a diverse community. And I would like now to introduce one of the household names of the Nordics, which is Wallenius-Sol, and their Axel Stenhammer, responsible for operations. Axel, please, what do you think about the initiative?
Yes, thanks. Yeah, we've been part of the initiative for a while now. I would say we're kindred spirits because Wallenius-Sol was created by Wallenius and Swedish Orient Line, identifying an optimization opportunity in the northern part of Europe. Paper producers having each their own system and each have their own vessels chartered and bringing down paper to the continent. And by us being able to collect all these volumes onto fewer keels, we optimize the flow and the transport chain. So I would say that's the same, more or less, what Virtual Watchtower is doing, collecting data that's out there and optimizing it and making it visual for even competitors, but being a neutral part in optimizing the supply chain. So for us as a shipper, it's maybe not obvious what the benefits are, but for our customers, it's obvious to optimize and being able to visualize the whole chain. And that's, of course, is important to us. It's interesting, the tools with planning and vessels that we see. I would say we have this knowledge already, but it's always good to have it visualized in the system and also for our customers. And I would have a question really if this tool would be able to be increased. For us, it's interesting to see our utilization or what will happen if we encounter, or say, bad weather. We are forced to delay one day. What would be the effect for our customers? Would it be possible to see how much cargo would miss our connection? And if we could elaborate to switch rotation, call a port first, because then there's less cargo missed, so how we would optimize our vessels also collaborates with the virtual watchtower's information. So I don't know if that's a question for you to take up, the simulation tool, if that could be expanded to the cargo as well, so we can plan cargo, because that's the real benefit, I would say, that with the virtual watchtower for us, we also will be able to plan our utilization and optimize our vessels. And also being a single point for our customers, instead of each cog of this machinery reporting and trying to collect it. Virtual Watchtower will collect it and package it to all parties in the system. That's a benefit for all, I would say.
So yeah, this is an excellent moment to raise that question, right? And I think that there are at least three people who can give an answer. I start with Mark, and it could be Per, could be Vidya. But Mark, do you want to give it a shot? And we are approaching the end. A short, is it possible? Yes, but maybe a little bit more.
Yeah, of course it is possible, and that's exactly also the aim and the nature of VWTnet, and also what we are doing as an individual company is to share data across the landscape and try to share it with all the actors, because a logistics chain is a complex ecosystem where you have shippers, you have terminals, you have ports, you have shipping lines, you have tugboats, so it's a very big ecosystem. And yes, of course, it would be nice to be a single node to provide as a center for information, all this information to the different actors, so that we all possess the same information. Because today in the world there are a lot of different truths out there. And then the question is, which one do I choose? And I think,
Thank
yes,
you, Mark.
there we can make a big contribution.
Thank you very much. Vidya, what's your vision?
I think the vision here, Wolfgang, is really getting people to say that the information they put into the system is not going to be used against them. So, for example, if I'm a very small transporter in the whole ecosystem and I'm late for some reason, I should have the ability to put my information in knowing it will not be used against me. I think a lot of this came up in the beginning. A lot of people are scared to put information in because it would seem like it's their fault. Information is information and it benefits everybody. So if we can build in an ecosystem that says, hey, listen, put in the information, and it's not liability. It's about letting everybody else know, we could build such a better world.
Thank you, Vidya. Yeah, we have also H&M on the call, Michaela Kenne, who is the Logistics Innovation Lead. Thanks for joining. Any thoughts from your side, Michaela?
Yeah, for us at H&M, tracking and monitoring our shipments deliver both end-to-end visibility across our supply chain, but also it creates situational awareness across all function and teams internally. So, for example, receiving alerts is very valuable for us that enable us to take more proactive decision making. But in addition, also to have an estimated time to arrival allow us, for example, to plan and also prepare our warehouses to receive the goods more efficiently.
Thank you very much, Michaela. And I see also Jan Bergstrand from Trafikverket. Jan,
yes.
Your thoughts?
Yes, hello, thank you. Yes, the source is from Trafikverket side that we are, first of all, good for you to know maybe that we are the infrastructure manager for all transport modes in Sweden. So we are the Swedish Transport Administration. And why do we engage ourselves and even sometimes finance things in the data sharing field? Yeah, we've been active in Federated, a European initiative, where we were coordinating 23 labs, among 10 was in Sweden, and we consolidated them to 3 now, where one is virtual watchtower concept, and another was also mentioned by Michael here, is collaborative decision making. So this is a couple of things, and why? Yeah, of course it's good for us as an infrastructure manager to help out with the political objectives with Green Deal and make a smooth transfer between the transport modes, enabling, for instance, rail, sea rail initiatives to run smoothly. And that gives also an effect of using the existing infrastructure better, which is good for us, as this is a huge and long-term investment always. So this is two reasons. There is also other initiatives that could be maybe supported, and horizontal collaboration is one assignment that my colleague Catherine Wallin is working on since years for the governmental side, and this body can maybe help out with such initiatives. There is also new upcoming initiatives like here in Europe, like FT, paperless transport, and also another new initiatives with platforms similar to Federated and so on in so-called EDICS, where we could maybe have concepts from virtual watchtower included. So that's a bunch of reasons for Trafikverket to engage and sometimes also finance those initiatives. I'll stop there, I think.
Thank you, Jan. Clearly there are a lot of projects that can mutually support each other, like EFTI and others. Before I go to Chris, Axel, did you get your answer?
So yeah, more or less. It's just a quick question for you to elaborate on, but yeah.
Axel, thanks a lot, and we can get on the call and discuss this in more detail. Yeah. Thanks again for your question. So now I would like to hear from Chris Kosmala what he thinks, then after Michael, you can take over.
Thank you, Wolfgang. I have to say, at the high level, the initiative is really interesting from the perspective of the terminal operators, because we believe that greater visibility of the events in the supply chain that the shippers actually have would speed up the flow of cargo through terminals. I actually liked a statement from Axel, who was talking about the utilization of capacity related to the ships. Well, we are also constrained by capacity. We are not indefinitely available parking lot for the shipments.
We still have a lot of people in the session, but there might be a lot of questions, and please reach out to us so that we can answer them, and I hand over to Michael for the closing and final remarks.
Thanks a lot. And I would like to say, wow, what a fantastic first 2 years this has been for the first phase of VWT. And I mean, this community-based initiative is really a true international collaboration where a lot of actors are joining forces to respond to the needs of the shippers and also to our society. We have run 20 living labs and very many workshops aligned with those. We have had 103 weekly updates, I think it is, Kenneth. We have, at the moment, 157 monitor shipments with 5 new ones added for each shipper every week. And we have piloted VWT in 3 prototypes, and in the last one building on the twin architecture, which seems to be very, very promising. So, having said that, we would like to extend our invitation now, and the VWT community, to shippers, transport operators, terminal operators, research bodies and authorities to join this movement, and also to create what Trish and Abhinay mentioned, the CDAB lab for transport. So I hope to see you all in the future in actually joining forces with us and co-creating something that actually would make a difference for the supply chain industry. So, thanks a lot for listening.